Hello, welcome to the season 10 of the course of Rhino. At this session, we're going to work on some of the commands of the Formation Tools toolbar. Following that, we're going to practice their countless applications and several examples. So at the beginning, I maximize the perspective view, and then I open the Deformation Tools toolbar, and then in the continuation, we're going to talk about the commands here. So I fix it here, and as you remember, we have talked about flow along surface, the first command in the previous sessions, actually in the season 7, and at this session we're going to cover the others. For example, the first command that we're going to talk about is twist, and as the icon and as the name shows, the twist command deforms objects by rotating them around an axis. For instance, here I wanna create a box from this part, corner to corner, then I click on center, and then I draw it from the origin point, check it out, like this way, then I set the display mode to shaded, Ctrl-Alt-S or Ctrl-Alt-G to ghosted mode. Well done. After activating the ghosted display mode, I wanna start twist, then I select the object. Following that, we should draw the start and end of the twist axis. Then here we can pick two reference points to define the rotation angle like this way. As you can see, this was the whole process of twist command. Ctrl Z. Then right now for the axis, I draw a curve like this from the origin point vertically. By this way, I draw a curve and then I change the object layer, and I just have drawn this curve to tell you that the twist axis that we specify in twist command, the axis is held in common. Following that, I click on twist to start the command. Following that, I select the object. Following that, press enter. Then the start of the axis, I started from the origin point, and then just like the end of the vertical line, check it out. After that, you can use a click for the first reference point, and then move your mouse and then specify the second reference point. And another approach that we got in twist is importing the rotation angle manually. For example, 180 degrees, check it out. So after typing the angle, we can have the specified object twisted. Well done. Ctrl Z. Then I start twist again. Right now here, if I specify the object like this way, and then for specifying the axis, I do not extend the axis to the end. I specify the end point at the middle part, and then I rotate it. As you can see, only the specified axis is twisted, as you can see. And also I can specify a range, or I can specify a part of the box for twist. Then I rotate it at 45 degrees by this way. As you can see, only the specified range of the box or the object is rotated, while others are straight. Now it is something like the previous sessions examples. That was the project of Kimball Art, that as you remember, we modeled the timbers and the building by using some specific commands. Again, twist to check out the other points. For example, the first point. For example, I specify the start point at the origin point and then the middle part of the box at the end point. But I want the object to be rotated totally. I want all of the parts to be twisted. So here we can use infinite. We can set it to yes, and then if yes, the deformation is constant throughout the object, even if the axis is shorter than the object. However, the result right now is different with the other results at the previous examples. So just let us consider the differences. Here I create a copy, and then I start twist. I select the object, then I draw the axis along the box 180 degrees. Then for the another one, I draw a shorter axis, then I set infinite to yes, and I type the angle 180 degrees. I mean, at such a context, the twist applies only to that part of the object that we have specified the axis. But when we set infinite to yes, it assigns the rotation angle for the unspecified part too. And as we have specified 180 degrees, and since the specified axis is half of the object and the specified angle is 180 degrees, so the rotation for all of the object would be 360 degrees. So when the length of the axis is shorter than the object, then the angle of the twist applies to the all parts of the object. But note that if we set infinite to yes, here at the next point, I extend it to the midpoint. I set infinite to no. Here we can set copy to yes. Here the copy option specifies whether or not the objects are copied. And then here the plus sign appears at the cursor when copy mode is on. Then check it out. You can click and then create some copies. Following that, let's check it out at the perspective view. Look, this is the result, like this way. And for the straight section parts, here we can open the Rhino options and then mesh, custom, and then control the density. Check it out. So we can control the displayment of the objects to the extent. Control Z, ghosted mode, and then move on. I remove this object. Following that, I scale 1D. Then I specify the object, then the base point. Check it out. Like this way. Great. Following that, I select the object to array it linearly. 8 as number. Then I array, check this out. As you can see, following that, I want to extend the axis to the top part. Following that, I select every other object to change the object's layer so that we can display them in different colors. And then I create a copy like this way. Here I start twist, then I select the objects to rotate them. Then I specify the axis for the whole objects. Following that, the angular first and second reference points. I import 90 degrees. Then here if I press enter, we will have such a result. Check it out. But let me set copy to no. Again, the axis, setting copy to no, 90 degrees. Check it out. As you can see, all of these objects are considered as a single object. I mean, even from the beginning to the end, they are considered as a unified object, and the rotation angle has been assigned to the entire objects. So the point here is that when we use twist for rotating a set of objects like these, then according to the specified axis, the first and the start object and the end object are twisted according to the specified rotation angle, and they are unified. And in other case that it may happen with twist, for instance, the objects, the axis, and then I set rigid to yes. Following that, the rigid option specifies that individual objects will be deformed as they are transformed. So if you specify 90 degrees, then individual objects will not change, only their positions will change. And as you're concerned, using rigid option or not is based on your needs. I mean, sometimes you want the individual objects to be transformed as well as they are positions, but sometimes you don't want them to be changed, but their positions. That in the continuation for the assignment, we're going to work on a practice in which you should set rigid to no. I mean, when we create the floor, we array them and then we twist them. Sometimes we don't want the objects to be changed, so it is totally depends on our needs and what we want to model. And about the specifying axis, you can draw a slanted axis like this way. I set rigid to no and then 90 degrees. Check it out. This is the result according to the specified axis. Or for example, This time I specify a different axis and then 90 degrees. Look, a different result. So as you're concerned, we can model different types of geometries by using twist and specifying different axes. In the continuation, we're going to talk about some practices and then expound our knowledge about using twist. Here in twist, here the first practice that we're going to do is modeling such a form. For example, we can work on these and other similar model geometries. For example, to do this, we should start drawing these vertical curves, which are twisted back to Rhino. And then I draw a circle like this way, following that by using a vertical line. Check it out. I draw the vertical line, following that array polar from the origin point, 16 at numbers and 360 for the fill angle, and I can place one of these curves at the origin point by this way, and then I change the object layer red so that we can find it better easily. And at such a condition here, even we can lock the layer in which we work on. So as you can see, the red curve is not selected since it is locked. Then we start twist. We specify the axis and then the angle. Check it out. And then by using mirror command, we mirror the twisted curves, and then we will have such a result. So as you can see, just by twisting the curves and mirroring them, we managed to create these. And then pipe, we managed to create such a form. And then we can extrude the surface or the curve. Ctrl Z to undo the process. This time I wanna start twist again, and then from the start to the midpoint for the axis, and then at 360 degrees, and then mirror from the origin point. Check it out. And then we convert them to pipes. Look, this time we got a different model. As you can see, or even we can specify the start and end of the axis different from the previous example. For example, we can specify a range like this way, then mirror. I hold down shift to restrict the direction. Check it out. And then pipe as usual, so that we can observe the model, and then extruding the curve. Well done. Check it out at the rendered viewport. So by using twist, we can create such a model easily. And if we wanted to maximize the size of the openings between the pipes, then we can specify a fewer value for the rotation angle. Check it out, for example 90 degrees, and then we mirror it. Let's check it out. Then the openings of the pipes, as you can see, they are greater than before. And then pipe, check it out. So by just modifying the rotation angle, decreasing it, we could have modified the density, or even if we do not create the pipes, we extrude the surface by extrude curve actually. And then we're gonna split the surface by using these curves. Check it out. Then in the continuation, I want to select every other splitted surfaces. Check it out. And also for the bottom part, I select every other splitted parts opposite to top part of such surface. I do not flip the direction. Then 30 centimeters for the distance. Let's check it out. You see, then we will have such a result, as you can see. Let me select some other splitted parts, these diamonds, and then we can assign some new materials. For example, here at the front view, we can click and drag and then select these diamonds. Following that, in material, custom, then we can specify a simple material, blue, and then adjusting the transparency. However, at the future sessions, we will talk about the materials and how to specify them. So I just want to tell you, don't worry about the lighting, materials, and rendering. We will talk about them later. But today I just wanted to talk about the twist applications in the projects. I delete these objects and I unlock the layer so that we can delete the vertical line as well. So we talked about twist command comprehensively. In the continuation, we're gonna talk about another practice. For example, let's check this photo that we're going to model it. Wait for a second, please. Look, or for example, this one. We're going to create one of these. So to create these, here at the front view, by the polygon, inscribe polygon. According to the picture, we had a square, but here I specify 6 for the number of the sides. Let's check it out. And then from the origin point, I draw the polygon with 6 sides, and then by using offset, then by through points, check it out like this way. I offset the polygon like this way, and then extrude curve. I specify the distance, and then by using array polar, I want to array the polygon or the actually poly surface at the front view. Array polar, check it out. Origin point, number of the items 16 at 180 degrees. Here, as you can see, all of them are overlapping each other. So if we want to consider a space between them, Z offset, then I import type 15 or 10. 10 is better. 8. All in all, we got such a form. And I increase the numbers 20. 6 for the Z offset. Well done. Following that, I want the base part to be straight, so I can create a box and then position it at the base part of the polygons like this way. And as I'm going to cut these polygons, I adjust the position like this way. Following that, I select all of them and then Boolean difference, and then check it out, and I remove this curve for the box. So guys, we're almost done. And then in the continuation, we can assign the material. This time I wanna assign a more professional material here from the library in wood. Let me see. And as I told you before, at the future sessions we will talk about the materials. So for now it is not needed to be worried about materials. All in all, this is the result. Check it out. And here even we can show the surface edges. Check it out. Alright, this is the first example that we modeled it by using offset, extrude, and then array polar. And then in the continuation, I want to create a planar surface for the base part. I move it like this way to place it at the construction plane. Well done. Very well. Let us continue the lessons. Up to this point, we talked about twist command, which enables you to deform objects by rotating them around an axis. And the practice that I wanna assign for you is this building that you are supposed to model it by using twist command. And as you can see, the name is turning torso, that we will talk about it comprehensively. And then as usual, it's time to model it together step by step. But before that, let me check these. For example, if we want to model such a geometry in which we got 3 cables which are rotating or they are twisted, So to do this, back to Rhino, and then I pick the curve and then I draw it vertically on the construction plane, and then by using array polar from the origin point 3 as number at 360 degrees, let me specify 0 for Z offset. Check it out, we're done. Then in the continuation I place one of them at the center and then I convert them to pipes 1.2 for the radius. Check this out. And then we can select all of these and then we start twist. Then the axis from the origin point to the end at 360 degrees. Check it out. This is the final result at the rendered viewport. Well done. I'm gonna repeat the process from dealing with array polar, origin point, number of the items. This time I want to specify 4 and I want to delete the center curve at 360 degrees and then this at offset 5. Then I select them to pipe them 1.5 for the radius and then finally twist from the origin point for the axis, and then at the front view I enable project, then I extend it to the end. Check it out. Well done. Let me try again at the front view for specifying the axis. Check it out. And then the rotation angle 360. Following that, this is the final result. Look, we can model such a geometry by using twist, pipe and the vertical curves, and then assigning the material. And I want to create or customize another material like this way. Check it out. In 3 different colors that we used: twist, pipe, array polar, and vertical curves. So simply.